Welcome to Ask and Learn.
So, in this question, we have been asked that we have to balance the redox chemical reaction and then we have to calculate their E naught and then state whether the reaction is spontaneous or not. So, we will start with part A. So, we will take one half of the reaction, which is Mn2 positive goes to MnO2. Okay. And now we will balance the oxygen atoms first. So oxygen atoms can be balanced by two water molecules here. And now since we have 4H atoms on the left hand side, we will add 4H positive atoms on the right hand side. And to balance the charge, we have two positive on the left hand side. So we add two electrons on the right hand side to have the overall charge balanced. So this is the oxidation reaction. Since we undergo loss of electrons, two electrons, and now the next half of the cycle or the next half of the reaction is cobalt 3 positive goes to cobalt 2 positive. And now this is clearly a reduction reaction since we just need one electron to balance the whole chemical reaction. And since this is undergone by a like a gain of one electron, so this is a reduction reaction. Now we will have to add these two equations to balance it. So to cancel out the two electrons or the electron portion, we will have to multiply the reduction reaction by 2 to cancel this out. Okay, and now the overall equation will be Mn2 positive plus 2 water molecules plus 2 CO3 positive, which goes to form MnO2 plus 4H positive plus 2CO2 positive. Okay, and now this is our balanced chemical equation. And now in the next part, we have been asked to calculate the E naught of the cell. So if you see the appendix D, the reduction takes place at cathode. So our E cathode is 1.82 and our E anode is 1.23. Okay, and now to calculate E naught cell, it's E naught cathode minus E naught anode. So 1.82 minus 1.23, which is equal to 0.59. Now to state if the reaction is spontaneous or not, what we see is the E naught of the cell. So we know that E naught of the cell is greater than 0, and when it's greater than 0, it's a spontaneous reaction. Okay, and so this was part A, and now we go to part B. So once again we take two halves of the reaction. So first we take the first half. Okay, AgCl goes to form Ag plus Cl negative. Okay, so since we don't need any oxygen or hydrogen atoms to be balanced, we just balance the charge by adding one electron on this side. So this is a reduction reaction. Okay, and the second half of the reaction is NO goes to nitrate ion. Now here we will have to balance the oxygen atom and hence the hydrogen atoms as well. So to balance the oxygen atoms, we will have to add two water molecules here since we have three oxygen atoms on the right hand side. So we have to add two water molecules in order to balance the number of oxygen atoms. So three are present on the left hand side now. And now we have four hydrogen atoms. So to balance that, we'll have 4H positive. And now since you see the charge on the left hand side is 0, whereas on the right hand side is 3 positive, we balance it by adding 3 electrons. And now since the reaction occurs via the loss of electrons, it's the oxidation reaction. And now since we have to add the two equations, to cancel out the number of electrons, we multiply the reduction reaction by 3. So the overall reaction or the total balanced reaction comes out to be 3 AgCl plus 2 water molecules plus NO, which forms 3 Ag and the electrons get cancelled. I didn't show that, but yeah, here is it. 3Cl negative plus NO3 negative plus 4H positive. Okay. And now, if you look at the appendix D, the reduction occurs at cathode. That means E naught C is equal to 0.22 volt, and the oxidation occurs at anode. Therefore, E naught A is 0.96, and E naught cell comes out to be E naught cathode minus E naught anode, which is equal to minus 0.74. Now, since E naught is less than 0, the reaction is not spontaneous. Yeah, hope that helps.